Yes. No. Anyone have any homework questions that you want me to go over? There are 3 homework due on this coming Wednesday. Tomorrow by midnight. It will be 2.3, 3.1, and 3.2. So there are 3 homework due. So just want to point it out to you. So 2.3, 3.1, and 3.2. So these 3 are the homework that is due on this coming Wednesday here, tomorrow by midnight. Does anyone need help or any questions you have? And if you guys do have any questions with these 3 sections of homework, please talk to me after class. I do have my office hours. So today we will concentrate on chapter 5, where we do probability. Chapter 5 is where we do what we call as a discrete probability distribution, where the random variable that we're doing here is in the discrete mode or discrete variable. Discrete variable means that you cannot have decimals. That means that the number that you give to me is going to be a whole number like 0, 1, 2, 3, 4, 5. Example would be like number of keys you have, number of siblings, and so on. And then probability distribution usually is the form of a table where the left side is what we call as the random variable x, and the right side is the probability px. Okay, so these are the probability distribution. There are 3 requirements for a probability distribution. The first requirement is that every random variable x must have its probability. So like the 0 must have a probability. That is the first requirement. Second requirement is the sum of the probability is 1. So this big little sum e sign means summation. That means when you add all these numbers up, this probability, you should get 1. If you get a 0.99 or 1.001, it is acceptable. And each probability is between 0 and 1 included. So like every single probability that you're given to us, it has to be between 0 and 1 including. So you cannot have a probability above 1, and you cannot have a probability that is a negative. Okay. And then yesterday we stopped over here where we talk about the population mean and population standard. So once we get into this probability distribution, you can actually find the population mean and population standard. So we are not doing sample like what we did in previous chapter 3 here. So in chapter 5, what we do here is the mean essentially belongs to the population. So the symbol for population mean is mu, and the symbol for population standard is sigma. And again, we are not using this formula. We are using StatCrunch. I will show it to you later on what is StatCrunch is. Again, I think I mentioned on yesterday's class, if you do your online homework, if you say, help me to solve this or get any help or watch a video from the online homework, they were actually using these 2 formulas. Okay, so I do not use formulas, as I mentioned. So I will use StatCrunch. So the next thing after we do this is called the expected value. So what is an expected value? Expected value is something that we expected from. So example is, let's say if I collect data from you guys about the number of siblings, I can find the expected value means that if I go to the next class or next sample, I can expect how many number of siblings that you guys they have. Okay, so this is kind of what we call expected value, means how we expected this many people in this case. Okay, in in this class and the other class and in the next class. So I'm expecting to see like, 3 siblings or 2 siblings. I will tell you how to figure out. I'll give an example here how we figure out. So how do you find the expected value? Expected value is denoted by E. Expected value actually is the same as the population mean. Okay, so just want to point out to you. So if a question asking you to find the expected value is the same as the population mean. Okay, so if you find the population mean, that means you found expected value in this case. Okay, so let me show you how to use your stack crunch here. So this is pretty important since we do not use any formulas. So in StatCrunch, how do we do this is you make sure you have to enter data into your StatCrunch. So make sure that your random variable X is entered in var1 and your probability in var2. When you do your homework, you have a little rectangle stuff on the corner. You can import it to your StatCrunch so you do not type it out. And then you go to Stat Calculator Customs, where the value ins, you pick var1, and weights in, you pick var2, and then you hit compute. Okay, so I will definitely show it to you how we do this in your StatCrunch. So let's say we want you to find the population mean or the expected value, they are the same thing, and the population standard deviation for this case. Okay, so we have given to us this. So we find what is the population mean mu and what is the population standard deviation sigma. And don't forget the expected value is the same as the population. So first, I have to enter this number, the x 0, 1, 2, 3, 4, 5, 6 into variable 1. And then the probability px is in variable 2. So I'm going to get out my StatCrunch out here. Okay. So var1 here is where you enter this number 0, 1, 2, 3, 4, 5, 6. And var2 is where you enter your probability. Now I do not know if they take. Let's see if they take this. If they're not, then I have to change it into decimal. I think it might not work. Okay, so I think I have to change to decimals, and then we'll see. Okay, we'll see. And then we have, once you enter these two in var1 and var2, you go to Stat Calculators Custom. Okay, so you go to Stat Calculator Custom, which is the very end there. And the values in var1, weight in var2, and compute. Yep, I think that's the reason why there is a error here, is because I need to convert this into decimals. So I'm going to change it to decimals. This is 0.214. Yep, I think that's the reason why I'm thinking 0.286. So I just need to change this from fraction into decimals. This is 0.071. Okay. So now I just convert everything into decimals here. So now repeat it again. So go to the Stat, Calculators, and Custom. And then values in var1 and weights in var2, and you hit compute. There you go. So this is the population mean mu, or we call that as your expected value. And then this is your population standard deviation. So the population mean in this case is going to be around 1.8. And the population selection is around 1.51. Okay. And do not forget that this population mean and the population selection can be represented by decimals, because some of you will be thinking about what do you mean by 1.8 siblings? You know, there's no such things. But when you find the population mean and population selection, we can have represented by siblings. So again, this is also mean expected value. So that means that I expected, if I go to the next class, if I don't even ask students, I expected they have 2 siblings. That's what my so you know, this is kind of something that we will figure out, is if I figure out what is the population mean or expected value here. So I expected around 2 siblings, but 1.8 siblings, which is kind of 2. So when I go to the next class, if someone say they have, I expected that classroom have 2 siblings mostly. Okay. So that's the meaning of what we call as an expected value. Now, right underneath the stack cruncher, you will notice about the PX, that is the probability. So now I'm going to do something also important. So I'm going to put it in here, more formulas here. So this is number 7. Okay. So when you do when the question is asking you to find the probability, make sure you guys understand what kind of word you're using. Example is, if a question is using the word exactly, then you have to use the symbol equal sign. Okay. If a question says more than, then make sure you use the symbol that is greater than. Okay, this is the symbol you need to use. Less than, then make sure you use the symbol less than, or fewer. Sometimes they use the word fewer than. So make sure you guys know the symbol you use. If you use the wrong symbol, your answer is wrong. If a question is asking for at least, this is very important word here, because you see that in your test here. Now, the word at least is greater than or equal to. Okay. So like tomorrow, example is, if say tomorrow I want you guys to bring at least $3. At least $3 means $3 or more. Okay. And the last word that we're going to use here is the word at most. At most in this case is going to use less than or equal to. So this is, again, I put this purposely in the formula here to tell you that this is super important. Again, this is in your coming up your test here. So why I'm bringing this one out is because when you guys do the the stack cruncher, they have all these 5 symbols. Okay, so when you click on this little box for the inequality here, or the symbols here, this is equal to. So in your homework, they don't use the word equal, they use the word exactly. So that's where you're gonna use. So what do you mean by exactly? Exactly means is exactly 2. So if you look at this, exactly 2 in this case is 0.2. Oh, this should be 0.286. Why does it give you a weird number here? Huh, this is weird. Exactly 2 should be 0.286. Let me do it again. That is weird. Let me check. It should be same as, that was weird. Okay, there's something weird here. Maybe the sum is not equals to 1. That's why it's supposed to be the same as this. Okay, the 0.214. That's why I say it's a little bit weird here. That's why let me add up the sum here. If the sum is not add up to become 1, now that's why you get the weird. Yep, this is more than 1. So that's the reason why. Yep, this is not 3, this is 2. Hello, David. I'm gonna make some mistake here. That's the reason why I came out to be weird here, is because the sum does not came out to be 1. So I make a mistake on this. This is actually 2 out of 14, so it's 0.143. Now this one should be better. So I make a mistake. So kind of feel like this is what happens when something is wrong here. So I will show it to you what's going on here. So when you do this in your homework or your test, you kind of know that you make a mistake. So so I will show it to you here. So again, I make a mistake instead of this is a 2 instead of 3. So now this is supposed to be add up to become 1. So I go back to the same thing, go to stat, go to calculators and custom, var1 and var2. Yeah. This is a correct one. So actually the expected value or the population mean now should supposed to be 1.926. So it's 1.93. With the standard deviation population size of 1.48. Sorry, that is my mistake just now. And how do I know my mistake is very simple, because when I do exactly 2, it should be came out to be 0.286. That's why the question just now, I make a mistake. There's a came out exactly the same. So the word exactly means 2. This is a probability. Now, if I say less than or equals to 2 means that you have to add the 0, the 1, and the 2. So if you add the 0, the 1, and the 2, because that's equal to, less than or equal to. So anything that is 2 or less. So if you add these 3 probability up in var2, you should get 0.75. And then when you do the at least means greater than or equal to 2. That means that is 2 and up. So if you add 2, 3, 4, 5, 6 probability, if you add all these numbers up, you should get 0.571. And then less than 2 means it is any number that is below than 2, not including 2. So that means in this case 0 and 1. So if you add this probability of 0 and 1 here, if these 2 numbers here, you should get around 0.429. And then when you do greater than 2 means any number that is above 2. So that means not including 2. So that means you do 3, 4, and 5, and 6. So if you add 3, 4, 5, 6, these 4 numbers up, you should get 0.285. So so your StatCrunch actually able to add it. And you can also look at the picture here. If you look at the greater than 2 means they don't include 2. They do 3, 4, 5, and 6. They add all the red ones. Okay. And then when you have an equal to, include the 2. So anything that is 2 and above. Okay. So these are the names. I just want to point it out to you so you guys can know what are them. And these are very important, especially when you do your homework here. So I'll be using this a lot in your tests. All right. So so that is how we do your finding your mean and your standard deviation of using your StatCrunch here. And once you find the population mean and the population standard deviation, we can use the range of rule of thumb that you guys are familiar with. So again, what is range of rule of thumb says? Range of rule of thumb says that anything that below the mean minus 2 times the population solution, anything below than that is significantly low. Mean plus 2 times the standard deviation. Anything above this is called significantly high. And anything in the middle is no significant. So this is kind of like very similar to what we did in chapter 3. So again, this is called a range of rule of thumb. What is it used for? It's used to figure out outliers, or some in the textbook, we use the word significantly low or significantly high. Okay. Now so this is something that we use to figure out outliers. There is also another way to figure out outliers here. That is called using the probabilities. Okay, so there are 2 ways for us to figure out outliers here. One is using our ROT, which is you guys familiar with. The other way is using probabilities. So in the test, you only need to show one of this way. Okay, you need one. So in order for if you're using the probability, in order for you to figure out significantly high, you find out the probability of that number or more. If that number or more is 5% or less, then it's considered significantly high. So I always tell my students here is you have to find what is the probability of X is greater than or equals to a number. Okay. So this number is usually given to us as the high number. And if this number is 5% or less, then it is considered yes, it is significantly high. I put H in this case. Example in this case is, if we use this example, the question is asking will be, is having six siblings in the classroom significantly high? Okay. Now, in order for you to use the probability, you just need to figure out what is the probability of getting 6 or more siblings. Okay, so what we do here is you go to your stack crunch, you hit this, and you do the because the question is asking for 6, so 6 here, you hit compute. So that probability is 0.071. So this probability is actually more than 5%. Okay, so your answer in this case is no. Okay, so in order for you to answer yes, this probability that you find here in your stack crunch has to be 5% or less. Otherwise, if for this case, your answer will be no. Okay. Same thing happens for significantly low. So for significantly low type, again, the probability of X or fewer has to be less than or equal to 5%. So same thing meaning of this, but this time we will not using greater than or equals to, be using less than or equals to a number. And that number in this case has to be less than or equal to 5%. If you have such case, then the answer will be it is a significantly low in this case. Okay. We can do the same question here. So usually when I ask for significantly high, we want the number to be high, like 5 or 6 or 7 or 8. And when we want a significantly low, we want a low number like 0, 1, 2. We never use a high number for significantly low and a low number for significantly high. That means I don't ask, is 0 a significantly high number? 0 siblings. We don't ask that. Usually when I ask for significantly high, we want like 5 or 6 or 7 siblings. And when we want for significantly low, we want 0 or 1 or 2 siblings. That means it's less. So we don't want to be the other spectrum in this case. So is 0 siblings, the question is having 0 siblings significantly low in this case? Okay. So in this case, in order for you to do that, you have to find what's the probability of X is less than or equals to 0. Again, where is this 0 come from? It comes from the questions. Okay, the question will tell you what number you use. And now you have to find this probability. You use less than or equal to 0. And that is actually 0.143. And unfortunately, this is also more than 5%. Again, in order for you to be significantly low, they have to be less than 5%. So since this is more than 5%, the answer will be no also, because this number is more than 5%. Okay. So this is the way that you can use probabilities to figure out significantly high and significantly low. Or you can use a range of rule of thumb where you take the mean, which is given to us by 1.926, 1.926. Minus 2 times the standard deviation, which is 1.48. So you can use that. Yes, you can use this range of rule of thumb here. So 1.926 minus 2 times 1.484. So that is actually negative 0.109. So this is negative 0.109. And then if you go for the high end, so become 1.926 plus 2 times 1.484. So this is 5 point something, 5.826. Okay. So the question says, is having 6 significantly high? Now 6 is, if you look at the number line, 6 is over here. So this say it is significantly high. But if you look at the probability, it says no. So actually this say yes, and this says no. So that means in your test, when you guys do this, your answer can change a little bit. That's why it is on the open-ended type questions here. So if you use, sometimes if you use a ratio rule of thumb, the answer is a little bit off. Like here, as I mentioned, if you use ratio rule of thumb, 6 is outside this range. So your answer is yes. But then if you use the probability, your answer is no. Okay. So depending, but I can tell you that mostly the reason why you get such a different answer, one say yes, the other one say no, is because we have a small sample size. I think we only got 14 students. That's the reason why that, this is based on 14 students. So that's why your answer is a little bit off. But if you have at least 30 students, more than 30 students, then you'll be having a pretty accurate answer. But let's take a look at the zero. Since the zero siblings is a zero sibling significantly low, zero sibling is smack right here because this is a negative number. So in this case, you find out that no, the answer, this one match. Okay, this one does not match. So I will try. I think when you do your test, these two answers should be the match. That means that if you use a ratio rule of thumb and you use a probability methods, they should match. So I will guarantee you, but the reason why this is not match is the one reason I can point out is because we use a smaller sample size. We only got 14 students here. So that's why it's a little bit off. Anyone have any questions with this? I will show it to you with some examples so you can know what it is. And again, in the test, you only pick one. As I put the word or here, means you pick one. Okay, don't use both. All right, now this question is asking us to identify if the given value is a discrete, continuous, or not a random variable. Now, again, discrete means it has to be no decimals. Make sure you guys know that. Continuous means you can have decimals. What is considered not a random variable? Not a random variable means that your variable is a categorical type. That means, do you have a credit card? Your answer is yes or no. Okay. Are you male? What gender are you, male or female? So those are all categorical. So if you have a categorical type, then it is not a random variable in this case. Okay. So let's take a look at the first example here. Exact weight of quarters now in circulation in the United States. So ask yourself, wait, is that a quantitative or is that a categorical? Weight is a quantitative. So which is this case, which is discrete or continuous. Can weight represent by decimal or no decimal? Since weight of a quarters can be represented by decimal, so this will be the continuous type. Okay. Number of toss required to get hits. So in the quarters, so if you take your quarters and toss it, and how many times you need. So how many tosses you get? So this is also numerical, which is quantitative. Unfortunately, the number of toss cannot be decimals. So because you get either 1, 2, 3, 4, 5, you cannot have a 2.5 toss. So this kind of word will be discrete. Okay. Any questions? C, respond to the survey question, do you smoke at least one cigarette in last week? Now, this is the word do you, so this is actually is a categorical type. So this is not a random variable, okay, because it is a categorical type variable. And number 1D, number of spins of a roulette wheel required to get number 7. A roulette wheel is actually a big wheel. If you go to the casinos and they put the little marble or ball in there and they will drop. So because the number of spins is quantitative and it is not decimals, so this is a discrete type. Okay. So usually when you see the word number of, it's the discrete type. I just want to point out. So you guys, I'll give you a hint here. So a hint here is if you see number of, usually is discrete. Okay, this is a little hint for you guys. So that when you guys do your homework, when you see the word number, when you hear the word number of tosses, number of spins, number of something, usually is discrete. Okay. Anyone have any questions in this case before we start number 2? So before we start number 2, the discrete is for chapter 5. So like if you do number of toss or number of spins, chapter 5. Once we do the weight, height, continuous type, chapter 6. Not a random variable, we don't do that in this class at all. Okay, there are ways to do the categorical type, but not a random variable one. So that is for the next class. If you're going for your next statistics class. Okay. Let's read question 2. Question 2 says that a company on this table is the random variable X is the representing the number of TV in a household. So how many TVs you have in your house? Okay, so that's your X. Again, this is a discrete type because of the word number of television. So that means that if you look at this table here, the X in this case represent by number of TV. Okay, that means you get 0, 1, 2, 3, 4, 5 TVs here. And these are your probabilities. Okay, so if you see the PX, this is your probability. So some of you were asking about units. So what is the unit for a discrete type? The unit in this case will be the number of TV. Okay, so so if we talk about number of spin here, then the number of spin will be the unit. The weight, I don't know what unit because it can be gram, it can be pounds, it can be ounce, you know. So usually if they use the number of, that would be the unit for this case. Okay. Question A is asking us, does the given information describe the probability distribution? So in order for us to do the probability distribution, you have to fulfill the requirements here. So when I ask you for this case, you have to go through the requirement check for the probability distribution. These are the requirements for probability distribution. Random X has a corresponding probability. The sum is 1, and the probability is between 0 and 1. So here are the first requirement. Every random, I'll just put every random variable, I just use the word RV, has its probability. Okay. This one is checked because if you look at this probability distribution, every X has a PX. Okay, you look at all the PX next to it. So that is checked. 2, the sum of all the probability is 1. Okay, so in order for us to check this, you take out your calculator and you begin to add all these numbers up. 0.02 plus 0.15 plus 0.29 plus 0.26 plus 0.16 and plus 0.12. So this is come out to be exactly 1. This will be checked. Okay. What happens if you get 0.999 or 1.0001? It's still checked. What happens if the sum is not exactly close to 1? Then it's not checked. Then the requirement does not match here. Okay. And the next one is the probability is between 0 and 1 included. So your probability has to be between 0 and 1. So that one is easy check by looking at this. 0.02 is between 0 and 1. 0.15, 0.29, 0.26. Every single probability you see here is between 0 and 1, including. So this is check here. So since they are checked here, the requirement here are met. Okay, so this is how we do this first question when they ask you, does the given information describe the probability distribution? You're checking for the requirement. Okay. Questions here. All right. So next you have to find the mean and the standard deviation. So in order for you to find the mean and standard deviation, you have to enter this probability distribution into your StatCrunch. So I'm going to use var3 and var4. 0, 1, 2, 3, 4, 5. And 0 0.02, 0 0.15, 0 0.29, 0 0.26, 0 0.16. So you're going to enter all this. And again, when you do your homework, I'll show it to you here. When you do your homework class, when you do your homework 5.1, you will get the probability distribution here. Make sure you use the little corner button there. So click on this for the table. And then you see a little rectangle here. Click on this, open in StatCrunch, and they will automatically import all this to you. So you do not need to enter like what I just did just now. So make sure you guys do that so that it will help you to save your time here. But in your test, you do need to enter them like what I just did here. And then how do you find the mean, the population mean and population selection? Go to Stat, Calculators, Custom. Okay. And don't forget, this time we will use var3 and var4 because I just used back the new table here. And once you hit compute, this will be your mean and this will be your standard deviation. So the population mean in this case is 2.75. And the population standard deviation is 1.28. Again, rounding 2 or 3 decimal places in the test. Okay, unless it is stated in the question how many I want, but otherwise 2 or 3 is something I want. So if you forget what is the unit is number of television. So that means that I expecting around 2 to 3 televisions that in your house right now. So even though I didn't know how many TVs you have in your home, but when you came to my class, I was expecting you have 2 or 3 TVs in your home right now. Okay, so that is how good or how the statistics work here, because it's kind of true. I mean, if you look at how many TVs you have in your house, you should have around 2 or 3 TVs in your house. Okay, that's what I'm expecting. Okay. All right, questions so far? Question C, range of rule of thumb. So the question is asking us to figure out what is the range of rule of thumb. So the range of rule of thumb is where you use the mean and the standard deviation. So you take the mean, 2.75, minus 2 times the 1.28, the standard deviation. And then the other one, you just need to add them. Okay. So this is the range of rule of thumb in part C. So you need a calculator here. So you take 2.75 minus 2 times 1.28. So this will came out to be 0.96. So this means that this is the number of TVs. So again, this is the unit. So for the plus sign, I'm going to do 2.75. 2.75 minus 2 times. Okay, this is something. Okay, I think something wrong with this. I need to change it back to my. So sometimes I do not like to use this calculator because change back to scientific. Sorry about that. I think I made a mistake. 2.75 minus 2 times 1.28. Yep, that's why I said something is wrong here. So this is 0.19. Okay. Because the other calculator doesn't use orders of operation. And then now do the plus one, 2.75 plus, sorry, 2.75 plus 2 times 1.28. So this is 5.31 TVs. So that means that if you know what is this range of growth time stays, it says that if you have 0.19 TV or less, is significantly low. And if you have 5.31 TVs or higher, that is significantly high. And if you have between these two number of TVs, no significance. That means that, again, if you have 0 TVs, yes, it will be significantly low. If you have 1, 2, 3, 4, 5 TVs, it is not significantly low or high. It's normal. But if you have 6, 7, 8 TVs in your home or higher, that is significantly high, because this telling us these are your range using range of growth time. This is your cutoff point in this case. Anyone have any questions here with the range of growth time? Okay. D, what is the probability of having exactly 3 TVs? If you want, you can just look at here. This is exactly 3 TVs. So how do we write this? We write it down as probability of X equals to 3 because of the word exactly. So if you remember what we just did in the formula, exactly is where we use the equal symbol. Otherwise, if you do not want to do this, you can use your stack crunch here. You just use the symbol equal to, and then you get the 0.26. Okay, so this is pretty much easy here. So this is what I expected you to guys write. So when you hear the word probability exactly 3, this is what the symbol you have to use. Okay, and then some of you will ask me about, how about unit, David? Do we need units? I will say that probability has no units. Okay, so make sure you guys know that. Probability has no units, so you do not put any units in. So this is the end of it. Okay. Question E is what's the probability having 3 or more television? So when you do 3 or more means 3 is included, so 3 or higher. So how do we do this is X is greater than or equals to 3. So this is called the 3 or more. So either you take this and you add them up, or if you want, you can just change this in your stack crunch to be greater than. This will become 0.54. Okay. So there are few ways you can do this. One way is just take a calculator and add these 3 numbers out. Otherwise, if you are lazy to add, you just use the word greater than or equals to 3 and you will get the 0.54. So this is the meaning of how you find this case. Anyone have any questions? Yep, this will be in your test. So yeah, this will be in your test. Yep. Put it down so you guys will get it. And the last one we're gonna do here is 2 a significantly low number. Okay. So in order for us to do significantly low, you can use range of growth time. So if you want to use ROROT, the one that we just did in part C, where is 2 at? 2 is right over here. This is 2 TVs. Okay. So since if you use the ROROT, since 2 is in the no region, so in this case, the answer is no. So no, because 2 is inside the ROROT range, inside the ROROT. So it's very easy to explain this. It's either the number is in or outside the range? Okay, since 2 is inside the range, so that's why the answer is no. If you answer yes, then the 2 has to be in the lower end. So that means the answer here. But since this is 0.19, this is 5.31, so 2 is in between this range, in between the low and the high. So that means you can use your answer no in this case. Or if you do not want to use the range of rule of thumb, you can use the word you can use probability. Okay. So in order for us to do the probability, you do Px is less than or equals to 2. The reason why we use less than or equals to 2 is because of the word significantly low. Okay. So just want to bring it out. So when you do the significantly low, we use x is less than or equals to a number, in this case 2. And how do you find this probability? One way is you can take out your calculator and add 2 or less. Or if you want, in StatCrunch, you just do probability less than or equals to 2. And that probability came out to be 0.46. Okay, came out to be 0.46. And that number is actually not less than, it's more than 5%. So your answer in this case will be no, because 0.46 is more than 5%. Okay, so this is 2 ways for you to answer question F here. Again, in your test, you pick one of this way, and I will guarantee you that both of these answers will be answered the same answer. Both of them is I will answer no in this case, but the explanation is going to be a little bit different. If you use the ROT way, make sure you have to build this table here. Otherwise, if you use a probability, you have to use your StatCrunch or calculator to add this up. And make sure the probability has to be 5 or less to answer yes. Otherwise, no, in this case. Question for me in this case. This homework is going to be due on the next Wednesday. So make sure you guys start working on your homework here, because there are quite a few homework going to be due on next week in this case. Okay, just want to point out to you guys. Now, next class is I'm taking attendance here. So make sure you guys, know what to do. Attendance. Taking attendance. So, so this is the end of the 5-1 here. So make sure you study question 2 here. It is going to be in your test. Okay. Next, we're going to do 5.2, which is a binomial distribution. So this is still discrete. Just want to point out to you. This is still discrete. Discrete case in this case. Okay. So, so for this section, we're going to do the binomial case. Okay. So, what is a binomial probability distribution? A binomial probability distribution have to meet all of these requirements down here. So there are 4 requirements that you have to meet to have a binomial distribution. The requirements are, number 1, so important stuff. So the procedure must have a fixed number of trials. So what does that mean in this case? It means, to cut it short, what does it mean here? It means that it needs to know n. Okay, so so that means that I have to give you n, or the question has to provide you the n, which is called number of trials here. Now, sometimes it's easy to figure out n in this case, especially if I give you a table like this. The very last number here is your n. Okay, so some of you will ask me how you figure out n. If a question gives you a table, then the very last number here is your n, and sometimes they will tell us how many people we pick randomly. Okay, so if you have the word, if you see the word here, the word randomly, how many people we pick randomly, that is your N in this case. Okay, we pick 5 students randomly, or 10 students, or 15 students, then that will be your N in this case. Okay, I will show it to you in some examples. Okay, so that is the first requirement. The second requirement says that it has to be independent. What is the meaning of the word independent? Independent means that the outcome of an individual does not affect the probabilities of the other outcome. For example, is I always tell my students for independent is, let's say that if I ask the first person, John, I asked John, was like, do you have credit cards? And he say, yes, I have credit cards. And then I asked the student next to John, let's say is Rachel. Rachel, do you have a credit card? You think Rachel's answer is based on John's answer or totally independent? That's why we use the word independent. And you know, Rachel's answer should be totally independent. The reason why is because her answer does not depend on John. Her answer is based on her own, right? And then when I ask another third student, which is David, David, do you have any credit card? And his answer does not depend on Rachel or John. It depends on himself. So that means it's totally independent. That means that his outcome is not affected by the rest of the outcome previously. Okay, so this is called independent. The next one we have in this case is it has to be 2 categories. So that means either yes or no, or boy or girl, or correct or wrong. So make sure that I just want to point out to you that we call it success or failure. Doesn't mean success is always yes and failure is always no. Okay, sometimes the success is no and the failure is yes. It depends on the question. Okay, sometimes the question wants to do the negative instead of positive. Okay, so I'm just want to point out to you guys. So it doesn't mean success is always yes, failure is always no. And the last one is the probability of success remains the same in all trials. Okay, so what I mean by that is that that means the probability that John answered that he has credit card or no is 50-50. And then when I go to Rachel, Rachel answers, does she has a credit card? Her answer is also 50-50, yes or no, right? Until she said yes or no, right? Same thing happens when I ask for David, it's also 50-50. That means that every trial, so every person, they have the same probability. In this case, 50-50 chance. The answer yes or no. Okay. So so if you have all these requirements fulfill or met, then you get what we call as a binomial distribution. Okay, questions? Now, the other thing you need to point out here is that this independence rule. So this is for number 2. So this is the independent rules that sometimes we call it the cumbersome rule, the 5% cumbersome rule here. Okay, so this is for independent purposes. Okay, so so this is a big keyword here. So if you pick something from a sample, if you've got a sample without replacement, now what is meaning when I say without replacement? Without replacement means you do not release back to the pool. Okay. So what do you mean by without replacement? Without replacements means that you pick someone else and you take it out. For example, is if I have this class, if I want to pick 2 students without replacement, so I pick the first student is John, and John will be released, will be not putting it back into the pool. That means that he will be taken out from the class, and then I will pick another student. Let's say Rachel. Okay, example. Now the second student. Now the reason why I say this is important is because when I pick John out from your class, the class size gets smaller from 15 to become 14, right? That means that the chances of me picking another student is getting better because your size is your sample size is getting smaller. Your class size is getting smaller from 15 to 14. So this without replacement actually is a dependent case. Okay. The reason why this is dependent case is because it depending on who I pick first. If I pick John first, then we know that John will not be picked again on the second time because he'll not be released back to the pool. So, but you know that in the binomial distribution, we have to have an independent case. So if you have a without replacement like this case, that's a big keyword you have when you look for it. Make sure that you can still treat it as an independent as long as your sample size is no more than 5% of the population size. Okay. So I just point out to you here. So this is called a cumbersome calculation here. So if your n over by capital N is less than or equals to 5%, then we can treat this as independent. Okay, means it's good news because our binomial needs independent. Okay, however, if you take your n over by capital N is more than 5%, then this will be back to a dependent case. And if you have a dependent case, this is no good because our binomial distribution says it needs to be independent. Okay, and some of you ask me what is n, and little n and small n. Little n is from the sample size. Okay, and then capital N is the population size. Okay, I'm gonna use a detailed signs here. So example in this case is, remember that I picked 2 students out of 15 of you guys. So n in this case will be 2. I picked 2 students randomly. Forget you always use the word random. So when you hear the word randomly, it means that's a little n. Out of 15 students in this classroom, so that means your capital N is 15. So if you can want to figure out this cumbersome room in this case, you take n over n. So it's 2 over 15. Where's my calculator? So 2 over 15 is 0.13. So this is around 13.3%. And since this is more than 5%, so this is actually dependent. So sadly, if I pick this case, it's not gonna go well in this case. Okay. So again, how do we know that we have to use this cumbersome calculation? Is this big keyword without replacement. Okay. So when you hear the word without replacement here, make sure you check the cumbersome rules here, these rules. Otherwise, if you don't have it, then you do not have to worry about checking these rules. Okay. So this is a big keyword. So make sure you guys know that. Next, we're going to talk about the notation. So these are the notations we be used in this chapter here. So capital S and F stands for success and failure. And I think I told you guys before already early on just now, success doesn't mean positive, failure doesn't mean negative. Sometimes it can be the other way around. So success can be no and failure can be yes. Okay, depends on the question. The P is the symbol that we use, is the probability of success. Usually this probability of success is given in the question as percentage. Okay, so when you read the question, it will say this is how many percent is that usually is the probability of success, usually is given in the question. Then we have Q. Now, Q is not given the question. And what is Q stands for? Q is the probability of failure. Usually is not given in the questions, and you have to use the formula. Q in this case is 1 minus P. And I'm going to put it right in this formula here, the formula sheet that we have here. This is number 8. This is very simple. I'm gonna put right here. It's a very simple formula here. Probability of failure which is called Q, is 1 minus P. Okay. So what does that mean by the probability of failure is 1 minus P? So example is, let's say that 20% of this classroom are male, then how many percent is female? So you just subtract it from 1 or subtract 20 from 100. So it'd be 80% or 0.8. So that will be the Q in this case. So usually the question give you the P, but not the Q. So you have to find it by subtracting it by 1, or you subtract by 100. Depends, are you using percentage or are you using the N in this case? Percentage of decimals, okay? N in this case will be the number of trials. Again, how do we know this is a number of trials? In the question, you will have the word N is randomly select. So you hear the word randomly. So that will be usually is the number next to it. So 5 randomly selected people, when that will be always your N in this case. Okay. X is the specific number of success in the trial. Okay. So usually this X is usually comes after the word probability. So if you want to find what is the probability exactly 2. Okay. So when you hear the word exactly 2, or at least 2, or at most 2, so this 2 is usually is the X. Okay. So make sure you guys know the difference between N and X here, because a lot of students get those two mixed up. And the word PX is the word of the word probability. Okay, so usually this is what I will asking you mostly. What's the probability of getting exactly 2 out of 5 randomly selected? So those are the one that we will be using. Okay. Now, formula. How do we calculate this binomial distribution? Again, if you don't have use StatCrunch, this is the formula. But I will tell you, do not use this formula here. So yes, if you do your online homework, if you do help me to solve this and so on, you will be using the formula here. But we will bypass the formula. As I mentioned, we're going to use StatCrunch. So in StatCrunch, you go to the stat calculators binomial, where you have to enter your N, which is your sample size, and your P, number of success. Okay. Usually you need to enter these two numbers here, your N and your P. Okay. And then again, you have the words. Those are the keywords that we just use here. If you have the word exactly, you have to use the symbol equal to. If you have more than or greater than, make sure you use the symbol of greater than. Less than or fewer, use this symbol. If you have the word at most or significantly low, you use the less than or equal to. If you have the word at least or significantly high, you use this symbol. And then the blank next to it, you put in the X. So you do need to fill in your X after you put in here. Okay, so it's very similar to what we just did here. You guys remember this? So these are the symbols, that the 5 symbols we have, and then this 2 that next to it is your X. And where you get your X from? After the word probability. Okay, so I'm going to add a little bit more to this list because we have the word at least. At least also used for this also used for significantly high. Okay, and this is used for significantly low. So if a question asks for significantly high, make sure you use this symbol. Significantly low, also make sure you use the other symbol. Okay, just want to point out to you guys. Okay. Now, the next thing we're going to do is finding mean and standard deviation. Now, we did find the mean and standard deviation back in this 5.1 here, where you put all this X in L1 in variable 1, and then this in variable 2, and then you just use your work your StatCrunch to find it. However, there is a shortcut to do this if it's a binomial case. Okay, So if you have a binomial case, the shortcut is that if that the mean is written down as n times p. Okay. And the standard deviation in this case can be written down as square root of n times p times q. Okay. Again, I don't have a square root symbol. So so SQRT means square root for me. So what do I mean in this case? As long as you have a binomial distribution, you can find mean and standard deviation using n times p, which is the number of trials times probability, and n times p times square of npq for the standard deviation. Instead, you can put this in your var1 and then var2, and then you use the custom calculator, the one that you just did in. I just put or use 5. Now, if you use 5.1, it's going to be a lot of work because remember 5.1 what we did last time over here. You have to enter all this in your StatCruncher, and then you go to the custom calculator, and this is the mean and this is the standard deviation that you guys did in 5.1. So guess what happened is that you will have to, if you do not want to use this formula, then you have to use it the way that you just learned in 5.1. Okay. Just want to point out to you, so this is the next formula here. So this is the 9th formula. I think this is almost towards the end of the formula here. Quite a bit of formula. Yes, some of you were overwhelmed. Oh my God, David, there's a lot of formula here. Yeah, that's why I let you guys use one piece of note here. If it's a binomial distribution, okay, you can find the mean, population mean, mu, is n times p, and the population standard deviation, sigma, is square root of n times p times q. Okay, make sure you guys know where is a square root in your calculator. So those are the mean and standard deviation. Now, once you find the mean and standard deviation, then you can begin to use a range of rule of thumb and the probability. This is again the same as what we just did on here, right? We can use the range of rule of thumb and the probabilities to figure out outliers, or in this case, significantly low, to figure out what is the significant in this case. So this is the same as the 5.1. So all these things is the same as 5.1. So I just literally copy and paste it, to be more honest. Okay. So this is all the same as 5.1. So so that means that this is to determine significantly. Okay, this is to figure out outliers in this case. So if a question asks about significantly, again, you can use this or this. So you can two choices here. You can use either ROT or the probabilities. Anyone have any questions with this 5.2 here? And class, this formula, please do not use it. Do not use this formula. You will cry if I show you how to use this formula. Okay, you would. I will tell you a lot of you will drop my class right away if I. So please do not use StatCrunch. Okay. All right. So question number 1. So that question is asking us, determine whether the given procedure result in a binomial distribution. So that means that we have to check for the requirement. So if the question is asking for whether this procedure result in a binomial or have probability distribution, you have to check the requirements. For those who are not binomial, identifying which one of this is not satisfied. So that's why you need to check the requirements in this case. The question asking for, we have a current Senate have 75 males and 25 females. 40 different senators are randomly selected without replacement. This is a big keyword that I will be, if you guys have do this in your tests, make sure you highlight or underline that word because that's a big keyword. And the gender of each selected senator is recorded. So so this is that's why I'm teaching you how to guys, when you read the questions, pick up the important keywords. When you see the word without replacement, this is where you have to perform that comparison rule, the 5% comparison. Okay, so this is where you're gonna do once you hear the word without replacement. This is the meaning of it, the 5% guidelines for comparison rule. This is only do when you have the word without replacement. So, but the first thing is we have to figure out what are the requirements here. So the first requirements that we have to do, okay, is you need to know number of troughs. In this case, n. Can someone tell me how do we find n in this case, number of troughs? What are the words we're looking for? For number of troughs n, we have to use what words we have. We will use the word randomly. Okay, so if you look at this question, what is my n in this case? My little n, number of troughs. Anyone? Where is the word randomly and what is the number? Yeah. So here is the random word. And how many people we pick here? We're picking 40. Okay. So our n in this case is 40. So this is checked because we know our n. Okay. So make sure you guys know that this is your n in this case. Once you hear the word randomly, that is your n. Okay. 2, independent. That is the second requirement. But you need to follow the 5% rules here because of the word without replacement. Okay. So the without replacement, the 5% rule says that you have to take n over by capital N. Okay. So we know the little n is 40 since we have 40 randomly senators are picked. But our capital N is how many total senators we have in the whole US. There are 75 males and 25 females. So your capital N in this case is 100. Okay. So so your capital N in this case is 75 male plus 25 females, which is 100. So we do have 100 senators in the United States because we have 50 states and every state is represented by 2 senators. So 50 times 2, you should have 100. So we know 40 over by 100. If you use your calculator, 40 divided by 100 is 0.4. Okay. So this is equal to 0.4. But unfortunately, this number has to be 5% or less. But we know 0.4 or 40% here is more than 0.50. So this is dependent. So this is no good. So because of this, then the answer is this is not binomial. Because it is not independent. Okay, so that's the reason why that so you do not, if you want, you can continue check the rest of it, but because of this rule does not satisfy, this is no longer a binomial. Now let's continue checking the rest of it. The third one says it has 2 outcomes. Because it's binomial, the word bi means 2. So that means that this has 2 outcomes. This is checked because we are recording the gender of it. So either you get male or female. Okay, so that is good news. Okay. The last one is the probability is the same for each trough. Now, this one is also checked. Some of you will say that, well, David, there are more male than female. So it's not going to be the same. No, I will tell you that this is chat. So let's say that you're picking 40 senators randomly, right? So you go to the House of Rep here, House of the House of Senate, right? So, the Senates in this case, and you pick people out. So let's say, what's the probability? What the first pick in the Senate here? Is that male or female? Is 50-50 chance. Okay. But David, if you look at the current Senate, there's more male than female, right? But why is still 50-50? Because the chances of you being picked, the chances of a gender being picked is still 50-50, no matter how much or how little the female or male in that case. Okay. So that is, and then let's say I pick a male. And then what's the chance of me the second time I pick? It's still 50-50 because I doesn't know until I pick it. Okay. And then what's the third chance? Still 50-50 male and female, no matter what happens on the first two of them are male or female. So that means that every time when I pick a sample, a new trials here, the trial is still having a 50-50. So it has a 50-50 chance to pick for all trials. Okay. So although the chances are not 50-50, but when I first pick it, because you doesn't know, right? When you pick something else, but you know that it's male and female. So the chance of you pick the first one is 50-50 until you pick it and you know. So actually everything worked except for number 2. This is the one that is not going to be in this case. Questions on the first question here. All right. Second questions. We're gonna question 2 is asking, assuming that when adults with smartphones are randomly selected, 54% of them use them in the meetings or in the classes. So this is important. So what is this 54% is? So if you look carefully on here, so these are the notations. So can someone tell me which is the 54% we call that? Is that your P? Is that your Q? Is that your N or your X? This is the only choices you have here. So 54% in here is given. Yeah, it will be given a question as what? Percentage, right? So this is actually is your P. Okay. However, your StatCrunch doesn't like percentage. So you have to convert it into decimals. So make sure you move 2 decimals to the left or you divide by 100. 54% will be 0.54. If you put 54% in your StatCrunch, they will give you error. Okay. So now we have question A. Question A is asking is 8 adults are randomly selected. Find the probability that exactly 6 of them use their smartphone. Okay. So so if this 8, is this 8 randomly selected? Is this 8 P, Q, and X? This 8, is that P, Q, N, or X? And what's the keyword I'm always telling you? This 8 has the keyword of what? Randomly selected. That means that is your what?
Letter N.
That's your N. Yes, because of what. That's why I need to teach you guys how to do this so you guys will not get wrong here. So that means that this is your N. And how about this exactly 6? So what is this exactly 6 will be?
X.
That would be X, because as I mentioned, X is the one that comes after the word probability. So when you hear the word probability, And the word exactly, what symbol should we use for the word exactly? We should use the symbol of what? Equal to. Okay. So this case, you have to use x is px equals to 6. Okay. So now we're gonna go. I'm gonna teach you how to use your StatCrunch to figure this one out. Okay. So you have to go to Stat Calculators Binomial. So go to your StatCrunch. Okay. We don't need this anymore. We go to Stat Calculators Binomial. So on 5.1 we do custom, and 5.2 we do binomial. So they will ask us to put in two information first. Your n in this case is 8, which is your number of trials, and your x is 5.54, which is the 54%. Okay, so that means that in question 2 A, B, C, D, E, the 54% is used throughout this whole question. That means your P is the same for all these questions. Okay. And since the question asks us to use a probability to find a probability that is exactly 6, so this is your answer in this case. So how do you write your answer, class? Just write down the very last sentence in your StatCrunch. You see the StatCrunch here? So the very end here, the very last sentence, just write the whole thing in there to make a full point. Do not give it to me as 0.147, 0.1469. In your test, you won't get full points in this case. So make sure you use, you give me the whole stuff in this case. Okay, so this is what I want you to give to me in your test. In your homework, you just give me as 0.147 because the homework wants you the answer straight away. But in the test, make sure you give me everything. Everything in this case means the last row. Okay. Questions? Anyone? All right, let's read question B again. So this time we got 20 adults using smartphones that are randomly selected. What's the probability that all of them use their smartphones? So we know that this 20 is your N, right? Because of the word random. What do you mean by all of them? So all of them means exactly 20. Okay, so this is the meaning of this. So if a question says that all of them means all of the 20, exactly 20. So in order for you to do this, you have to change your N to become 20 in this case, because we got 20 randomly adults, randomly selected people, students, and 54% still the same, but you need to find exactly 20. That means all of them. So if a question say all of them, means exactly the same as 20. So this is the probability. So px equals to 20 is 0.0. Now this is hard. So for me, you can write how many 0, 1, 2, 3, 4, 5 zeros here, 4, 4, 5. But in the test, you can give me as 0 because if you round this in 3 or 2 decimal place, it's still 0. If you give it to me in the homework, make sure you give it as 0. You do not need to put in so many decimal places in there. So that's how we do question B. Anyone have any questions? Question C. 10 adults are randomly selected. You have to figure out that what is the probability of at least 8 of them. So again, we know the 10 is your N because of it randomly. At least 8. So this is your probability here. So at least, anyone know what symbol should we use for at least? Is that equal, greater than, less than, greater than equal to, or less than equal to? Which symbol should we use for at least?
Greater or equal to 8.
Yeah, you have to use this symbol, greater than equal to. So in this case, this is super important, class. That's why if you do the wrong symbol, you get it wrong here. So N in this case is 10 because we're asking for 10. at least 8. So you're going to do greater than or equals to 8. Okay, so this is the meaning of at least 8. So this is your answer in this case, 8 or more. So in order for you to do that, again, I need the last line in your stack crunch. Px is greater than or equals to 8. Again, I don't have the greater symbol. This is 0.089. Okay. Again, depends on how many decimal places you want to round, and also make sure you read the question really carefully in your homework and your test. Especially your homework. They want 3, make sure you round to 3. Okay. The 12 adults are randomly selected. What is the probability that fewer than 3 of them use the cell phone? So what is fewer? I mean, this is n, and it's 12. Fewer than 3. So which symbol should we use for fewer than 3?
Less than or equal to 3.
No, we're not going to use less than or equals to 3. Okay. So fewer is this one. So this is also used for fewer than. Okay, so make sure you guys know that. So for fewer than, you only use less than. Okay. So just want to point out to you so you guys do not make a mistake here in the test. So fewer than is the same thing as less than, no equal. Okay, just less than. Okay. So in question D here, you have to use n is 12 because we are picking 12 people here. Less than 3. So make sure you change. Is that 3 is the one I'm looking for? Yep, less than 3 is the one. Yep. So, oh my God. So this is the answer in this case. So, so in part D, Px less than 3, or in this case, fewer than 3 is 0.009. 0.10, actually, the 5 is big enough to round up. So if you use the less than or equal to, this will be the wrong answer. Okay, so make sure you guys use the correct symbol for this case. Okay. And lastly, for part E, the question is asking for if 6 are randomly selected, is 5 is a significantly high number. So when you do significantly high, there are 2 ways for us to do significantly. So either you use range of rule of thumb or you use the probability. Now, range of rule of thumb, you need to know your mean and standard deviation. But the question here does not provide us mean and standard deviation. You have to find them. It's not difficult. But the best way for this is we find the probability. Okay. So we're going to use the probability method in this case. And the word significantly high. So what symbol should we use for significantly high? If you look at the pink one. So significantly high, the symbol we use is what? Greater than or equal to?
Equal to 5.
Yep. So what we do in this case is we have to change the n to become 6 because we're using 6. So we had to do greater than or equals to 5. Okay, not just greater than or not both greater than, so significantly. So this came up to be this. So the probability in this case of x is greater than or equals to 5, because the question asks us for 5 here, is 0.1515. And unfortunately, this number is more than 5%. Okay, since this number is more than 5%, then the answer is not. 5 is not significantly high because the probability is higher than 5% in this case. Okay. So this is how we do question E here. So we're gonna end today's class because it's past the time here. So when you come back tomorrow, we will continue the rest of this 5.2 in class here. So also I will tell you more about your midterm on next Wednesday. So so this is your make sure you understand this. This is pretty important here. So make sure you guys study this. So it is coming up in your test here. So make sure you use the stat crunch. Do not use the formula. I can kind of, if you have time, I can show it to you what happens if you use formulas here. If you do your 5.2 homework and you try to use formulas in this case. God, let me to log in here. So you will see that how difficult it gets here. Oh my God. Kid, he doesn't like me. Okay, I'll just show it to you so you guys know what it looks like. And please do not do this in your test. They use a formula. This is how much work you have to do. And I will not, that's why I say do not use this formula. This is how much work you have to do here. And then, so that's the meaning of that. And then you have to find out. It's a lot of work, class. I will recommend you do not do that. So I will highly recommend you guys to use StatCrunch. Okay. So if you get a tutor, make sure the tutor know how to use StatCrunch to do the work here, because we're not going to use any crazy formulas like that. The only formulas you need to know is this kind of formulas. Again, it's not that difficult. Okay. It's a pretty easy formulas right now. All right. So that's it for today. Does anyone